Hey there, and welcome to Surface Properties, North versus South. um, in this video, should be a relatively short video. Basically, I'm going to discuss the differences between the North and the South, and they're very stark, as you will see when I show you Google Mars, which you may have already used in class on an activity. But starting with the North, actually, let's just start with Google Maps, just to give you a good picture. Alright, so this is just about the entire surface of Mars. You can see, if I scroll left, the crater here, this huge crater appears on the other side. So this is essentially the entire circumference of Mars. It's not quite, I can't fit in the entire height of it. Here's the very north tip of Mars up here, and very south. But you can see a very distinct line, basically cutting the planet in half. What do these colors represent? Mars doesn't have to be represented in these colors, really. This is what Mars looks like in black and white. Not quite as impressive. You can't really tell as much what's going on, although it's a little easier to see some features like the ice up in the polar region and the top of the mountain here, the volcano, Olympus Mons. But in elevation mode, you got the scale here, and you can see darker colors going into Roy G. Biv backwards. So violets, blues, indigos are deeper. Doesn't mean, and you could kind of think that maybe this is if there was water on Mars, like liquid water in large quantities like on Earth, this is where the oceans and maybe a lake would be. But that doesn't exist. It's really just dry desert type land. And so think of this as lowlands, as if water might be there if it were present. You can see, interestingly enough, that in all these higher regions, you get this, actually what is the deepest part of Mars. It's kind of an irregularity, whereas the rest of the lower lands are up in the north. And quote-unquote sea level, one way to think of it is if there were oceans or bodies of water, the boundary between, see right here at 0 kilometers, the boundary between yellow and green, like so I'll move along with my hand here. This boundary is probably where if there was water at sea level, it would run along this boundary. Right? You might have some rivers here and whatnot, but anyway. So you can definitely see the north is low, down here below quote-unquote Martian sea level, and yellows and reds going up into the whites are really high. This to me you can think of as like snow on the mountain peaks. And so these really high volcanoes, tall volcanoes, if they were in Earth-like conditions, might have lots of snow on them. Anyway, I'll come back to that, but so the north is known for being lowlands. How they got there? Not quite sure at this point. If you're interested in Mars, maybe that's something you might want to study later on. And let's see here. I'm just gonna fix the typo there without you seeing it. Anyway, yeah. So how they got there? Interesting. There's some interesting theories out there, but no one's really very sure, to be honest. And they're also known for rolling volcanic plains, which are very similar to the lunar Maria. So here you have the moon, right? And there's darker spots, which is essentially dried, hardened, solidified lava. Most likely, most of these came about from large impacts, and then that would have kind of melted the surface of the rocks into a lava form, and then they would have cooled and formed what used to be long time ago, used to be thought of as Maria, as like bodies of water on the moon. And on Mars, they look a bit different. And not only do they look different, but they're much larger than those found on Earth. This little line you can't see on this resolution, but the next screen you'll see. This is 20 kilometers. This line. That's huge. You don't see lava flows this big on Earth. And this is would be the more recent lava flow. This is all pretty much lava plains, but you got some lava flow here, and it looks like it's older, been covered with more dust storms, sediments, whatnot. These are probably a bit more fresh. They're higher, so they're a new layer of lava. Something that's interesting to note: this crater here doesn't seem to be as affected by the lava flow. Maybe this crater is newer, or maybe it was just deeper with like higher walls, whereas this crater, kind of out in the arguably older lava flows, looks like it's been overrun with lava flow, and it's about the same size. So maybe this one was just as deep as this one at one point. Who knows? But it looks like this one kind of got overrun with lava at some point. And if you happen to have 3D glasses, this is the same picture I just showed you with the two craters. This is impressive. If you have cyan and red glasses, put the cyan lens on your right eye and the red lens on your left eye, and just pause the video and look at this. It's so cool. This becomes like super deep. It's really neat, and these planes pop up. You can tell they're definitely higher than these ones. If you don't have a pair of 3D cyan red glasses, highly recommend getting some. In fact, I'm going to pause the video and then bring up a website, maybe of a location you could get some. Hold on a sec. Alright, I'm back. That was quick, huh? I found some on Amazon. Wow, I just have a cheap pair of these paper ones that I actually got from the Container Store with a 3D notebook. It's kind of cool. But wow, these are nice for only $1.60. Oof, I might get myself a pair of these. Look at these styling ones. Dang. So any of these would work as long as you have cyan, because a lot of the astronomy ones, they don't use blue, they use cyan. You can get blue ones, and it's like a darker shade of blue. Don't get those. Get the cyan ones. They're definitely more useful. But yeah, I highly recommend it. This is a beautiful picture in 3D. And then we got the south, the southern highlands. These are actually on average roughly 5 kilometers higher than the north lowlands, and you can see that on the Google Mars page. These blues look like they're about maybe 4 to 5 kilometers in depth, negative 4 to 5, and these reds here and yellows are maybe like 2 to even 3. So just between that's 5 or 6 kilometer difference. Really extreme, and this line here marks out that boundary very, very abruptly. The southern highlands are heavily cratered. This is a snapshot from that, but again, if I bring it over, look how few craters there are up in the northern parts. And there are some, but look compared to the south, they're just everywhere, and you'll have bigger ones and smaller ones and the bigger ones and smaller ones and the smaller ones and the bigger ones. You know how you can use rings on a tree to figure out its age? The more rings, in fact, 1 ring per year pretty much, and the more rings, the older it is. This is a very similar process where the more craters, the older the surface. It's just, craters don't happen all the time, but they happen, every once in a while. Probably more often earlier in the formation of the solar system, but they don't happen all that often. And so, if you have more of them, that means this ground has been left undisturbed for a long period of time. It's not that they all would have hit down here for some reason, and there's some like magic shield up here. They would have hit. They're random, so they would have randomly spread out all around the planet. But something came along more recently and covered up the older craters, and just the newer ones that hit after it was covered up are present. So that's a very strong piece of evidence to show that whatever happened up in the north to make it so low happened more recently, and this is younger terrain than this terrain down here. And oh, it's also possibly thought that this crust is the original crust from the formation of Mars. Um, so yeah, we'll talk more about some of the specific features like this strange, really deep hole in the southern highlands in another video. So hope you enjoyed this one. Get some 3D glasses. I'm gonna put some more 3D pictures up in these videos, and yeah, good stuff. All right, talk to you later.